Okay, this video is the beginning of using algebra to solve exponential equations in pre-calculus. So I kind of did a little overview thing. I know you guys have watched the video on your notes, but just to kind of summarize one more time before we practice. So remember, you have been using inverses for a very, very, very long time to solve equations, all right? Inverses are opposites. So I gave this equation here, 3x plus 4 equals 7. If I wanted to solve this, I would subtract 4 on both sides, and I would have 3x. And the reason why I used subtracting 4, because it's the opposite of adding 4, so you're undoing it. So it's using an inverse. Now I have 3x equals 3, and the 3 is hooked to the x by multiplication, so I'm going to divide each side by 3, which is the opposite or the inverse, because division is the inverse of multiplication, to undo everything to figure out that x must be 1. You've been doing this a very long time. So now we're using exponential functions, and we're doing some exponential equations. And when I go to solve exponential equations, logarithms are the inverses of exponential. All right. So I've kind of made this up, and it's very general, and there's going to be times when it's not always going to be true, but for the most part, when you have an equation that you need to solve, use normal math first. And what I mean by that is I want you to simplify using adding, subtracting, multiplying, dividing, and all the tools that you've been using your whole life in math to simplify an equation. Okay? Then when you get to the point where you have the exponential function isolated or you can't go any further, then I want you to natural log, ln, everything to undo and solve. And the one thing I want to stress is I want you to ln everything. ln everything. I do not want you to use log or base 10. Okay? There's a method to my madness, and there are times when log would be a little bit easier, but in real life, you're going to have more base e in natural functions or the natural base of e. So I want you to ln everything. So to make things simpler in pre-calc, that's what we're going to do. I don't want you to use log. I don't want you to use your calculator with your log base button. I want you to natural log. Now, things to remember, okay? Once you log, or ln, which is the same thing, we say the word log. Once you ln, you now have 3 rules. The 3 rules are, if it's multiplication, I can pull it apart with addition. If it's division with here, I can pull it apart using subtraction. Okay, so those two are too nice. The one we use a lot is a natural log of a to the x. So if I want to bring the exponent down to solve for it, I can, once I natural log it or log it, I can bring the x down front, and I have x ln a. So we use that quite a bit. You can combine and simplify exponential functions if. So this is something I always remind. This is the part when you're doing your algebra, when I said, is there any normal math to do? This is one of the ones that kind of give people pause, is one, you can only combine exponential functions if one of two things happen. Either the bases match or the exponents match. So I kind of gave an example here. If I had e to the 5x divided by e to the 3x, because they have the same base and I'm dividing, I can subtract the exponents. Okay? Or I can combine them and simplify them if the exponents match. So here I gave another example. 5 to the 2x divided by 3 to the 2x. The bases don't match, but the exponents do. I can rewrite it as 5/3 raised to the 2x. Now, most people are familiar with this, and they can see that you can go this way, but they don't think that you can go back that way to simplify. So this one will give you a little pause, but it makes your algebra skills better. And remember, the bases have to match or the exponents match. So let's practice. And remember, only use natural log if you have an exponential function. Okay, so you can slow this down, rewatch it, write all this down, but this is in a nutshell how I want you to solve it. So in class, this is the first in-class practice, and we're going to solve these equations, and there's 8 of them on this page, but I'm only going to do 7. So I'm going to start out simple. I have 3 to the x equals 11. Well, the first thing I want you to recognize is that if I were to say, is there any normal math? There really isn't. I just have my exponential function isolated and equals 11. I also want you to notice that I know that 3 squared is 9, and 3 cubed is 27. So I know my answer is going to be between 2 and 3 and probably closer to 2 because 11 is closer to 9. So I just want you to know what you're doing before you get started. And the other thing is I want you to have 4 decimal places. So your answers I want you to have 4 decimal places because they're easier to check and it just makes it nice. And we're just doing algebra. Later on, we'll look at is that necessary, but let's look at the first one. So I have 3 to the x equals 11. I see that I cannot do any normal math, so I'm going to natural log both sides. Now remember, if you do one side, you have to do the other. Once you natural log it, I have natural log of 3 to the x equals the natural log 11. Now natural log of 11 is a number. I know it's ugly, but it's a number. But it's okay. Remember, we're undoing this equation. Once I do this, I see I can use one of my log rules that I can bring that x down front. So now I have x natural log of 3 equals the natural log of 11. And remember, the whole reason why we're doing this is to solve for the variable x. Now these two are hooked together by multiplication, so I'm unhooking them, and this is a number. I can divide both sides by natural log of 3, and I don't want you to do the decimal. I want you to leave it just the way it is, and say x is the natural log of 11 all over the natural log of 3. And thank God for the fraction button on your calculator. You can put it in just like that. I just want to remind you that once you hit the ln key, it's going to give you parentheses. So when you put in your calculator, you're actually going to have these in parentheses, and that's okay. Then I want you to write it like this because we're actually going to be rounding all of these. And when I do, you go 4 decimal places, you'll get 2.1827. So we just solved our first log equation. So let's look at our second one. I have 10 equals 4 to the x. Again, I'm looking at this to say, okay, if I was actually going to try to solve this using normal math, I already have an exponential function because my x is up high. I can't do anything normal, so I'm going to start doing natural logs to undo this. So I'm going to natural log both sides. When I do, I have the natural log of 10 equals the natural log of 4 to the x. Again, I recognize as soon as I natural log, I can bring this x down front. And remember, we're trying to solve for that. So I have the natural log of 10 equals x natural log of 4. This natural log of 4 is hooked to the x by multiplication, so I can divide both sides by the natural log of 4. So now I have x equals the natural log of 10 divided by the natural log of 4. And you can put that in your calculator and round it to 4 decimal places. And remember, again, your calculator is going to put that in parentheses where your number goes, and that's going to be 1.6610. Now, I always have people go, how do you check that? I said, take this number or the answer that's left and plug it back in here and see if you get close to 10, or plug it back in here to see if you get close to 11. It might give you the exact number, but sometimes it's really close because we have rounded. Okay, let's try number 3. So number 3 is a little bit different because now we're getting into, can I do some normal math? And I see that the 2 is hooked to the 5 to the x by multiplication. So I'm thinking I can divide both sides by 2. That is simplifying it before I even start doing anything. And I say, oh, yay, 25 over 2, and I want you to leave it that way, is equal to 5 to the x. Now I see there's no more normal math to do, if you will, and I'm going to start logging this to undo this because the x is up high, it's exponential. So I'm going to natural log this side, natural log this side. Once I do that, I have the natural log of 25 over 2, and I leave it that way. Don't mess around with it. I don't want you to use decimals, equals the natural log of 5 to the x. I now can use my log rule again. I told you I use this a lot, and bring that down front because, again, we're trying to solve for our variable x. And now I'm just going to switch places. X natural log of 5 equals the natural log of 25 over 2. I really don't want you rounding to the very end. I keep saying that, but it's so true. Now these are hooked by multiplication. So I'm going to divide this side by ln 5. So I have x is going to equal the natural log of 25 over 2 divided by the natural log of 5. And that's how you exactly put it in your calculator. So I'm going to put my equation, my little equal signs there, and I got negative 5.0. Whoops, wrong one, sorry. Let me erase that. And I was doing so well, too. So let's do this. This equals 1.5 5693. Okay, so we've done 3. So now let's look at 4. Okay, now 4, I have 2 times 5 to the x equals 11 times 7 to the x. So this one is going to give you a little pause. The first thing I said, is there any normal math? Well, yeah, there is. I can divide both sides by 2 or both sides by 11. It doesn't really matter which way you go. I'm going to divide both sides by 2. So if I divide by 2, I have 5 to the x equals, and I'm just going to write it this way, 11 over 2 times 7 to the x. Now, I'm looking, is there any more normal math to do? And I'm thinking, well, I wonder if I can divide both sides by 7 to the x. So I remember Mrs. Pond's rule that either the bases have to match or the exponents match, and the exponents match. So I'm going to divide this side by 7. So I have 5 to the x divided by 7 to the x equals 11 over 2. All right. Then I say, can I write that a different way? And I'm like, yeah, that is the same thing as saying 5/7 raised to the x equals 11 over 2. Now I've got it as simple as I can do it to start doing logs. So now I have all the normal math done. I've got to get the logs. So I'm going to natural log both sides. When I do, I have the natural log of 5/7 to the x equals the natural log of 11 over 2. Okay, and I recognize I can use my log rule, bring the x down front, so I have x natural log of 5 over 7 equals the natural log of 11 over 2. And then these are hooked by multiplication, so I can kind of divide by that whole glop, and you'll hear me say that a lot. I can divide all by the natural log of 5 over 7. So I have x equals the natural log of 11 over 2 divided by the natural log of 5 over 7. And when I put that in my calculator, this is what I tried to give you for an answer before. It's negative 5.0665. Now, I have a lot of people ask me, well, what if I divided by 11? You could. If you went the other way, just everything would be flipped, but you'd still end up with the same answer. Okay? All right, now I'm going to do number 5, and because I write so big here, I'm going to clear the ink on this page so that I can start with number 5 and not make it a mess. We only have a few more of these. Sorry about that. Let me go up a little bit. One more. There we go. I hate it when it does that. So we're doing 7 equals 5 e to the 0.2x. Now this one's fun because I look at it and say, is there any normal math? And I'm like, oh, sure. I'm going to divide by 5 on both sides because the 5 is hooked to the e by multiplication. So I have 7/5 equals e to the 0.2x. Now here is where you're going to start seeing the benefits of natural logging. Now there's no more normal math. I'm going to natural log both sides. And we all know that the natural log of e is 1. It undoes base e, and we learned that. We've been practicing that. So I can say thanks for playing. And let me get this out of here so it doesn't confuse us too much. And now I have an equation that says the natural log of 7/5, which is a number, by the way, equals 0.2x. Now this looks more normal. Now I have the 0.2x is hooked to the x by multiplication, so I'm going to divide. So x equals the natural log of 7 over 5 equals divided by 0.2, because I'm just going to divide by that. And then I'm going to put that in my calculator. And when I do, I get 1.6824. Okay, so that's fun. That's fun. I'm going to do one more on here. I'm going to wait and do 7 at another time. So let's do 6. Okay, 6 is a little bit more complicated. Now I have 2e to the 3x equals 4e to the 5x. So here I'm going to practice some normal math that might not feel so normal to you, but make it better. So the first thing I see, the 2 is hooked by multiplication, the 4 is, and I'm like, I can divide by 2 on both sides, or you can divide by 4, but I'm going to divide by 2. So I have e to the 3x equals 2e to the 5x. And then I said, wait a minute, I'm wondering, because these have the same bases, I'm wondering if I can divide by e to the 5x on both sides. So I'm gonna do that. So I have e to the 3x divided by e to the 5x. And remember, I'm just simplifying this using normal math, equals 2. And then I remember, oh, look, the bases are the same. So if the bases are the same and then dividing, I'm subtracting. So it's going to be e to the negative 2x equals 2. Now look what I just did. I took what was here in black and I did all this simplifying to get it here. Now I can't simplify it anymore, so I'm going to start undoing this and natural logging both sides. When I do with base e, I can say thanks for playing. I so love that. It undoes it. Negative 2x equals natural log of 2. And then I want to solve for x, and it's hooked, the negative 2 is hooked by multiplication, so I can divide. So it's natural log of 2 divided by negative 2. And when I put that in my calculator, I get negative 0.3466. You know what? Let's do number 7. I just won't do 8, so we're not going to do 8. Okay? So let's do 7, and then we'll call this video quits. I love this one here because it makes you really think what you're doing, and it's a little bit complicated, so we're going to do it step by step. I'm going to clear the ink from the page so that we can just concentrate on that one problem. So we're going to do number 7, all right? When I do number 7, the first thing is, so I'm going to write it up here so I have enough room, is this is what everybody says. Oh, I can do normal math. I can divide by 5. I said, oh, you can, right? But you got to be careful. Remember what I said is that you can only combine exponential functions. Let me finish writing this first. If I want to divide by 5, if the bases match or the exponents, and if you really think about it, this is hooked by multiplication. This is really 5 to the first. You just the multiplication is understood, and that's to the power of 1. Not only do the bases not match, neither do the exponents. So I'm just going to get rid of that because I can't divide by 5. Whoa. I can't divide by 5 to make that any simpler. So I'm just going to start at this point right here, natural logging. So I'm going to natural log this side and natural log this side, which you're like, whoa, this one really doesn't have much to simplify. Okay. Now, when I natural log this side, I have natural log of 10 to the x plus 3. I'm going to put in parentheses right now, equals, and this is where the mistake's made. Remember, this is multiplication. I can pull it apart using one of the log rules of adding. So it's a natural log of 5 plus a natural log of e to the 7 minus x. Now, the cool thing here is I can say thanks for playing. So the right-hand side is really natural log of 5 plus 7 minus x, which is really cool. And that's fun. I really enjoy that. The left side, I have to bring down my exponent, but because it's a binomial, I'm going to put it around parentheses around here because what I have to do is distribute, because natural log of 10 is a number. So you're going to multiply, you're going to distribute the x and the 3. So you're going to write it as x natural log of 10 plus 3 natural log of 10 is now going to equal the natural log of 5 plus 7 minus x. You're like, wow, this is long, which usually happens. It gets wide if you're natural logging. So I'm going to show you this. This term has an x in it. This term has an x in it. 7 is a number. Natural log of 5 is a number. And 3 natural log of 10 is a number. So what I'm going to do is put the x's on one side and the numbers all on the other. Since I have two numbers on this side, I'm going to move this over to this side and subtract it. And then I'm going to put the negative x over here. So I have x natural log of 10 plus x. So I'm going to move it over here. Equals a natural log of 5 plus 7 minus 3 natural log of 10. So I moved what I said I was going to move. This entire side is numbers, so we're good. Here, I still have to isolate the x, and this term has an x in it, and this term has an x in it. So here's what I'm always going to say. Factor out the x, divide by the GLOP. So if I factor the x out, I have a natural log of 10 plus 1, which is not the natural log of 11, but it's the natural log of 10 plus 1. So when you put this in your calculator, make sure there's parentheses around that. Okay, equals the natural log of 5 plus 7 minus 3 natural log of 10. Now, the x is hooked to this parenthesis by multiplication, so I'm going to divide by this whole GLOP here. You'll hear me say that. Factor out the x, divide by the GLOP. So I'm going to divide that whole side by that. Now I have x equals, ready for it? Natural log of 5 plus 7. And again, this is a natural log of 5 plus 7, okay? Minus 3 natural log of 10 is all divided by the natural log of 10 plus 1. So you put it in your calculator just like that, okay? And when you do, you get 0.5153. Now, I know this one's a little complicated, number 7, and look how long it is, but we're practicing this. I'm going to do it over and over again so you get better at it. So that's the end of this video for our initial part of solving